Hi, welcome back. This is Professor Ridge, and today's lesson's on section 8.6, quadratic functions and their graphs. Okay, so all quadratic equations are going to have a graph that's called a parabola. And so we start out with what I call my base graph, which is just your y equals the most basic quadratic equation, which is y equals x squared. So if we go back to the beginning of graphing, the way we do it is we pick numbers, plug them into the equation. 0 squared equals 0. If I plug in 1, 1 squared is 1. Plug in 2, 2 squared is 4. 3, 3 squared is 9. And then when I do the negatives, negative 1 squared is 1. Negative 2 squared is 4. And I learn about the shape of a parabola, y equals x squared. Let's plot these 0, 0. We call that the vertex. 1, 1. Got a mirror image over here. 2, 4. Mirror image here. And it makes this nice parabola shape. Okay, so and the vertex in this case is 0, 0. Got an axis of symmetry. At the line x equals 0. Goes through the vertex. Okay, so now if I want to graph y equals 2x squared, by order operations, I'm going to do the x squared first, then times it by 2. So what I do is I memorize this base graph, 0, 0. That's 0 squared, 0. And then I'm going to times it by 2, which still gives me 0. 1 squared is 1. So from my base graph, 1 squared is 1. And then times it by 2, that's going to give me 2. 2 squared is 4 times the 2. It's going to give me 8. So when I plot that, it's going to be 0, 0, 1, 2, and then I have my mirror image, negative 1, 2, then 2, 8, and my mirror image. And you see it's still going to be a parabola, but it's going to be a lot skinnier. Oops, you should hit your points. And then this one's going to be a lot skinnier too. It's a mirror image. Okay, so that's y equals 2x squared. If I were to go y equals, say, 1/3 x squared, I take my base graph, x, y, 0 squared is 0, times it by 1/3, you can still get 0. 1 squared is 1, times 1/3 is 1/3. 2 squared is 4, times 1/3, that's 4/3. 3 squared is 9, times 1/3, is 3. 4 squared, 16, times 1/3 is 16/3, which is about 1.333. Well, it's exactly 1.333. And that's exactly 5.3333. Okay, so when I go to graph that, okay, so 0, 0, 1, 1/3, 2, 4/3, and remember mirror image, 3, 3, and then 4, 5, and 1/3, mirror image. You can see this one opens a lot wider. So the 1/3 actually makes it open wider. It's compressing it, is what we say on the y-axis. It's compressing the y values, I mean. Alright, let's do one more about y equals a negative 1/2 x squared. So the negative part's going to flip it over, and the 1/2 part's going to make it wider. So again, 0, 0, 1, 1, 2, 4, 3, 9, Then we're going to times it by -1/2, 0. Remember, we square first. So 1 squared is 1 times -1/2. So we're doing order operations. 2 squared is 4 times -1/2 is -2. 3 squared is 9 times -1/2 is -4.5. And the negative is going to make it open down. So when I graph this one, okay, so we got 0, 0, 1, -1/2, mirror image, 2, -2, 3, -4.5, mirror image, and there we go. And that one's opening down. So basically, I just kind of memorize, if I do y equals ax squared, I'm going to do my base graph, 0, 0, 1, 1, 2, 4, as many as I want. 3 squared is 9, 4 squared is 16, so on. And then you're going to times it by whatever a is. The a, if it's bigger than 1, it's going to make it skinnier. If it's between 0 and, the absolute value is between 0 and 1. If it's a fraction, like 1/2 or 1/3, 2/3, between 0 and 1, it's going to make it fatter. Okay, it's going to, and then if a is positive, it opens up. If a is positive, so that's greater than 0, opens up. If a is negative, opens down. Okay. Again, and if the absolute value of a is greater than 1, it makes it skinnier. That's not really a math term, but and if it's between 0 and 1, it makes it fatter. Okay. So if it's like 1/2, -1/2, absolute value of it. All right. Now the next phase. Let's go to the next page. Okay, so the way I think of this, the graph of f of x or y, it doesn't matter if you use f of x or y, equals a parentheses x minus h close parentheses squared plus k is going to have the exact same shape as y equals ax squared, so we just care about that a, but the vertex is going to be shifted to wherever hk is. Now notice, in the formula up here, this is minus h. The vertex is at h, so you got to change that sign. Basically, we want this to behave like 0, so what does x need to be for x minus h to be 0? And it would be positive h. Okay, and then k, it's just, you just leave it alone. If it's plus k, this is plus k. If it's minus k, this is minus k. Okay, so h, the signs are different. K, you leave alone. So if I want to graph y equals 2x minus 3 squared plus 1, it's going to have the same shape. Oops. Same shape as y equals 2x squared. So I'm going to do my base graph, 0, 0, 1, 1, 2, 4, and then times the y values by 2. So, and it, but the vertex is going to be, is at 3, 1. So what I'm going to do is I'm going to pretend that the vertex is the origin, and plot the base graph. Plot these points, as if 3, 1 was the origin, pretending. Okay, so let me show you how this works. Okay, so what I'm going to do is I'm going to pretend the vertex 3, 1, I'm going to pretend that's the origin. And then from there, I'm going to pretend that's 0, 0, and from there, I'm going to plot my base graph y equals 2x squared. So 0, 0, 1, 2, even though that point is really at 4, 3, I'm pretending the origin is right here where the vertex is. So counting from the vertex, I go right 1, up 2. Going back to the vertex, I'm going to do 2, 8. So 2, 8. Oh, I didn't draw this down far enough. 1, 2, 3, 4, 6, 7. It would be up here in my words. And then my mirror image would be 1, 2, 3, 4, 5, 6, 7, 8. Right there. Okay, so I'm not going to draw my graph all the way up there. Just know it's going to go up there. Okay, so that's it. So it's just a matter of thinking your base graph, your shape, y equals ax squared. Do your base graph 0, 0, 1, 1, 2, 4, and then times a for just the y coordinates. So we get 0, 0, 1, 2, 2, 8. The vertex is at the point 3, 1. So plot there, pretend that's 0, 0 now. 0, 0, 1, 2, 2, 8. And then the mirror image is negative 1, 2, negative 2, 8, and then draw your parabola. Okay, so it's simple as that. Okay, let's graph one more, see if you got the idea. So I want to graph y equals negative 1/3 quantity x plus 1 squared plus 2. So my vertex is going to be negative 1, 2. Remember the h, you got to change that sign. It'd be negative 1. The k you leave alone. Okay, so my x symmetry is going to be through the x coordinate of the vertex. X equals negative 1. My shape of my graph is going to be y equals negative 1/3 x squared. So when I do it, I'm going to plot the points x, y, 0, 0. So I'm going to do the base graph. Just square the x coordinates. 0, 0, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. Then I'm going to times these by negative 1/3. Well, just the y coordinates. So we get 0, negative 1/3, negative 4/3, negative 3, negative 5 and 1/3. 16/3, same thing. Alright, so let me graph these. Okay, so I'm going to start at my vertex, negative 1, 2, negative 1, 2. My x symmetry is a vertical line that goes through that. Right, that's where I get my mirror image. And then I'm going to make my pretend origin, the vertex, and then I'm going to plot 0, 0, 1, negative 1/3. Do my mirror image point. 2, negative 4/3. Do my mirror image point. 3, negative 3. So I go back to my pretend origin, the vertex, and count from there. To the right 3, down 3 from the vertex. And then 4 will be 5 and 1/3. So counting from the vertex, I'm going to go to the right 4. 1, 2, 3, 4. Down 1, 2, 3, 4, 5, and 1/3. And I get my mirror image over here on the negative side. And I can draw my parabola. There we go. Nice and easy. So the hard part is just figuring out what the vertex is, which with this form, super easy. Next section we're going to tackle, well, what if it's not in this form? And then we'll learn how to convert it, completing the square. And then of course I'll give you a shortcut too. And so basically once you know the shape of parabolas, you do the x squares first and then times whatever a is. Figure out what the vertex is. In this case it was -1, 2. And then you plot those points, counting from the vertex. 0, 0, 1, 1/3, 2, -4/3, 3, -3, 4, -5/3. Do the mirror image points. And now you're ready to draw your parabola. Okay. Alright, so that concludes the lesson for 8.6, and I'll see you next time.